Good afternoon, everyone, and welcome to the introduction to the hydrogen data collection. As Sergio just mentioned, my name is Anton Bogachev. I'm an energy data officer here in the annual energy statistics team. And yeah, I would say let's get right into it. So I want to talk about different topics basically. So first, I want to look at the different key hydrogen trends that we observed throughout the last years. Then I would like to talk about the key concepts, also the methodology for reporting, and at the end, the key points for the actual reporting in the questionnaires that we have. Regarding the key hydrogen trends, I will start with an overview, then talk about production and demand, and then also about trade. So let's first talk about the overview as a whole. So over the last years, there were many investments or committed investment projects for hydrogen. So also the number and scale of these projects became larger and larger. All in all, though, hydrogen as an energy vector is still at a very early stage, and it also needs regular and effective tracking. And additionally, also because of different uncertainties like costs and also the lack of infrastructure for now, there are still quite a lot of barriers. But nonetheless, through these trends, we saw the need to develop a common methodology to, basically start the data collection for this commodity. And that is why we also came up with this joint Eurostat and IE annual questionnaire. So over the last years, global hydrogen demand has increased. So it almost reached 100 megatons in 2024, and it is expected to rise even more. Generally, this increase is mostly driven by demand for industrial products that use hydrogen as a feedstock. So it's not really, let's say, the main purpose is not, let's say, sustainable activity. So that makes up only around 1% of demand, though it is still increasing quite rapidly. So there was an increase of around 10% in 2024, but the base is still very low. So most of the demand is still, let's say, conventional and used as a feedstock. Regarding regions, it is visible that especially in China, North America, and in the Middle East, there the most hydrogen use is recorded by region. Exactly. So if we look at the demand in industry, we can see that it's also growing and that it is the largest basically use of hydrogen around the world with 55 megatons in 2024. And also, like from a year-on-year perspective, it is increasing. For example, it increased last year by 3%. Most of this demand, so around 60%, is for ammonia production, 30% for methanol, and 10% is in the iron and steel sector. And so, as we can see, yeah, the trends clearly show that the demand is growing. Regarding regions, we can also see that, especially in India and the Middle East, the demand is increasing, while in Europe it is going down. That also shows that Europe is more likely to import in the future rather than using it itself, producing it itself. And so generally we can see that hydrogen demand is growing and the growth is also accelerating over the last years. Now we will have a look at hydrogen demand in oil refining. So here we can also see that the trend is generally increasing or growing, though the growth has become slower in the last years. Oil refining as a whole is the sector with the second highest hydrogen demand after industry, just slightly below it with 43 megatons in 2024. And especially most of the growth in the previous years originated from the Middle East. And so generally also an increasing trend, but slowing down in the last years. Generally, global hydrogen supply rose by approximately 2% in 2024. And as already mentioned before, we are almost like around 100 megatons. Generally, there is almost no international trade today or very minimal. So basically, regional output also mirrors the consumption. And therefore, we can also see that, for example, China accounts for almost 30% of global hydrogen. And then also, as already mentioned before, followed by North America and the Middle East, both contributing around 15%. So it's very focused on a few regions in the world. Now, let's look at the electrolyzer deployment or also capacity. Here we can see a very dramatic trend comparing 2024 and the estimated 2025 figures. So there is a very large increase, especially again in China, where 50% of the new capacity growth is accounted to. And that is especially because of very large installations that are currently built up in China. So now let's look at the key concepts for hydrogen as a whole. We'll first look at some definitions, then at the hydrogen balance, production, trade, and transformation in refineries. This is like basically the structure. So all in all, hydrogen is a gas that is odorless, non-toxic, and highly combustible. We treat it in energy statistics like a derived or secondary product, similar to how it's done with secondary oil products. The unit of measure is terajoules and is generally used in the questionnaire. And regarding purity, there is this common methodology of using 98% of purity because it is assumed that below this purity level there is no real possibility or a need to use hydrogen. So what we are covering in the statistics is generally the intentional production and also the production as a byproduct. Then the consumption is both when it's auto-produced and auto-consumed, the quantities. And we also capture energy and non-energy use. What is also important is that we're not looking only at clean or green hydrogen. So it is not really like a sustainability accounting. We are accounting for all hydrogen. So as we saw also before, like in the conventional cases with oil refineries, for example, we really want to account for all hydrogen. Another important point is that we do not cover hydrogen that is present in other compounds. So only if the hydrogen is extracted from another compound, or if it is used to produce another compound, then we account for it. Otherwise not, except a few exceptions that we will cover in a second. And also we are not covering the hydrogen that is contained in intermediary products. That is also important. So regarding the exceptions, as I just mentioned, there are two of them. So those are, ammonia. That is a commodity that is, as we saw before in the trends, already produced and also exchanged a lot worldwide. There are different applications in both non-energy use, energy use, and it is also used as an energy carrier. And therefore, naturally, there is a lot of interaction with hydrogen. Another exception are e-fuels. So those are still, let's say, in a very early state. So also the production is quite low. But they are basically created through electrolysis, and the same also accounts for RFNBO. So those are renewable liquid and gaseous fuels of non-biological origin. And so for these, we also accept them and we also account for them in the balance, as can be seen later on. So the general structure is very similar to what you have also seen in other annual questionnaires. Generally, the biggest difference will be, as also just mentioned, with this secondary energy product. So those commodities that we just talked about will, as I said, will be seen more as a secondary energy product, and therefore it will be slightly different. But all in all, the structure is very similar, and that is, as you can see here in the graphic, it's very similar. So let's first look at production. So for, yeah, as already mentioned, it is not a primary energy product, hydrogen. It is seen as an energy carrier, and therefore it is also produced from different sources. For example, fossil fuels, renewables, wastes, electricity, nuclear energy, and also other natural sources. So for each of those sources, there is a different, basically, each of them has to be reported. And also, additionally to that, it has to be reported whether it is with or without carbon capture and storage. And therefore, there's this distinction for each of the sources. There's the distinction with and without carbon capture and storage. Then when we look at electrolyzers, there are also different sources. So for example, there's from direct grid electricity. So here it is really the electricity that is used to produce hydrogen, and has been produced from several sources in a like central power plant or any other type of infrastructure. And so most of it is from grid electricity. Then there is the specific case for electricity from renewables. So here it is if hydrogen was produced from sustainable renewables directly. Another one is electricity from nuclear. I mean, it's quite self-explanatory. If it is electricity of nuclear origin. And yeah, the last one is from fossil fuels, also quite self-explanatory. And for all other cases, there is from electricity others. And as you can see at the bottom of the slide, DL means direct line. So only the electricity production that is physically connected to the electrolyzer should be accounted for. Regarding production of ammonia and e-fuels, so the same accounts for ammonia. We need to look at all the different energy sources, so fossil fuels, renewables, waste, electricity, nuclear energy, and other natural resources. So this has to be reported, and also the ammonia has to be reported regardless if it is for energy or non-energy purposes. Most of the ammonia production as of now comes from natural gas. So that is the most common that can help with the yeah, with seeing what is most relevant. Then also regarding e-fuels and RFNBOs, those can also be reported here, also from the different sources. So it is basically very similar, but as I already mentioned before, it is still at a very early stage of development. So this is less relevant as of now, but yeah, it will be reported here. Now regarding trade, so as also in the other annual questionnaires, what is most important is focusing on the country of origin and of the final destination when talking about trade. Most of the hydrogen trade as of now is done by pipeline. And other options include, for example, the transformation into ammonia, as mentioned before, and then it can also be traded. All of the transformation losses that are that happen during these processes of transformation will be recorded under transformation losses. So also quite, let's say, straightforward. And if there is any other form that is used for the trade of hydrogen, it should be reported in the remarks sheet. So let's talk now about transformation. So here you can see the different types of transformation there are for hydrogen. So the first one is basically in electricity and heat plants when it's directly used there. So obviously for electricity, heat, or electricity and heat. The second one is in gas works and gasification plants. There it is converted to gas. The third one is the Haber-Bosch process, where the hydrogen is transformed into ammonia. And last but not least, the Fischer-Tropsch process, where e-fuels are created from hydrogens or through the electrolysis. Here we can see the different uses in refineries. So basically how hydrogen exactly is used in refineries. And typically there is hydrocracking that is applied in crude oil refining. Basically, hydrogen is used there to improve the hydrogen carbon ratio and to arrive basically at a broader range of end products such as gasoline, kerosene, and diesel fuel. There is also hydrosulfurization, where basically sulfur is removed from natural gas and from refined petroleum products, as the name basically says already. Then there is hydroisomerization. So basically, their normal paraffins are converted into isoparaffins, and because of that, the product properties are improved. And the last one is de-aromatization. And here, basically, aromatics are hydrogenated to cycloparaffins or alkanes. And yeah, exactly. So those are the different applications in refineries. Now I would like to talk about the key points for hydrogen data reporting. So in the actual questionnaire, here you can see that the structure is very similar to the other questionnaires that we have. So we have the supply, where production and stocks are reported. Then we have consumption, where transformation and energy sector own use are reported, and also the final consumption by sector. Then we have the table for trade, imports and exports by origin, similar to the other questionnaires. And the last one is infrastructure, where we track the capacity. Here we can see the basically the linkage to the other questionnaires. So since we use the production from these other sources, it is highly interconnected with the other questionnaires. And yeah, you can basically see how exactly they are interconnected on this slide. So to have a look at the actual questionnaire, here you can see what I just talked about before. So you have the different sources like from natural gas, from oil and petroleum products, and so on, always without and with carbon capture and storage. And also below you have from electricity, electrolysis, and from also from other sources like from hydrogen, from ammonia, and from e-fuels. And exactly, so as just before mentioned. What is important again is that we really account for all hydrogen. So as already mentioned before, not only the clean hydrogen, let's say. Another important thing is the intentional production or as a byproduct. And also, as mentioned before, we track both energy and non-energy use. So now let's look at table 3, transformation and energy sectors and losses. Um, Obviously, the indigenous production that is reported here should match the total in table 1. Imports and exports should also match the totals in table 5. We also track international bunkering, but it is not expected to be filled in the coming years yet. So it is already there, but most likely not used yet. And all in all, as already mentioned, the distinction between transformation inputs and energy sector own use is just like in the other annual questionnaires. And what is also important is that there is a distinction between the losses during the transformation process and the losses due to transport and distribution. Now let's have a look at table 4. So there we have final consumption by sector. In the energy use part, we have hydrogen used as a fuel. So for example, for cars or heating in the residential sector. And for the non-energy use, we have hydrogen as a raw material, so more like a feedstock. So for example, hydrogen that is used in the iron and steel sector for direct reduction of iron, or for example, also in the refinery process in oil refining. Here you can see, yeah, our other products, as also in the other presentations. I want to thank you for your attention, and if there are any questions, I'm also happy to answer to them now. Thank you very much.